Okay, so we have multiplied the first equation by 2. We're going to take that second equation. I want it to be a 6x. I want this to be a negative 6x to cancel it out. So I'm going to take all of this, multiply it by 3. Any questions? Negative 2x times a positive 3 is a negative 6x. The reason we're doing both of these steps is to get this 6x and this negative 6x, they will cancel. 3 times a positive 3 is a 9 times y. 17 times 3, I don't know that off the top of my head. 17 times 3 is 51. And again, we are combining them, okay? You are adding this together. 6x and a negative 6x cancel each other out. 9y plus 2y is 11y. 51 plus a negative 18 is the same as 51 minus 18, 33. Good. I want y alone. So, oh, sorry. So I eliminated the x's. Now I just have one variable, so I can solve for that variable. So 11y equals 33. I'm going to divide by 11. Y is 3, right? So what I have done is I have found that there is an x value for which when I put in 3 for y, that x value will make this true and it will make this true. Okay, so now I can take either one of those equations and put in the 3 for the y. I just pick whichever one looks a bit easier if that's an option. So 3x plus y equals negative 9 looks easier to me. So I'm going to take 3x plus, instead of writing y, I'm going to put the 3. Okay. I'm substituting the 3 in for this top, for y in this top equation. Equals negative 9. Any questions? So that is that, but with y equals 3. I'm going to subtract 3 because now I want to find my x. I still don't know what x value is. So I'll solve for x. 3x equals negative 9 minus 3 is negative 12. Divide by 3 because I'm still just solving for x. X is negative 4. So what do I have now? What have I done? I have decided I want to solve using an elimination method. I want to eliminate a variable. It does not matter if I chose to eliminate x or y. It would have been easier to eliminate y, right? I would have just only had to multiply this top one by a negative 3, but I chose the x's. So I multiplied this one by 2 to get a positive 6. I multiplied this one by 3 to get a negative 6 so that the x's disappeared. When I carried that 2 all the way through to the y and the negative 9, I got 2y equals negative 18. Here I got negative 6x, 3y times 3 is 9y, 17 times 3 is 51. Good. When I subtracted, I got these, or sorry, when I combined these, the x is eliminated. I got 11y equals 33, solved for y. Now that I have one of my variables in a 2-variable equation, I can put that in and solve for the other variable. I get y equals 3 when x is negative 4. If I was to make that a point, because we're talking about one point that is true for line 1 and line 2, if I make this into a point, it's the point negative 4, 3. So if I put 3 times x plus y equals negative 9, if I put the negative 4 in for my x, and I put my 3 in for my y, it's true for the first equation, and then I'm going to try it for my second equation, okay? My second equation was negative 2x plus 3y equals 17. Again, I'm going to do negative 4, positive 3. So negative 2 times negative 4 plus 3 times 3 equals 17. That's a positive 8 plus a positive 9 equals 17. So that's also true. Good. Or you can put this into Desmos and this into Desmos. They should cross at the point -4, +3. I don't want to do that because I feel like it's going to take valuable time. But I encourage you to do it so that you can check all your answers. Again, we're going to eliminate a variable because we can't solve for something that has two variables, right? Reduce the number of variables from 2 variables to 1 variable, solve for that variable, and I have half of the work done. I put it back in, solve for the other variable. Good. Here, what can I do? I have 5x plus 2y equals -5, or I have x minus y equals 6. They're lined up, right? So I got the x's on x's, y's on y's. That's good. I have a 5x and a 2y, and then I just have x and a -y. So I can do either the x's or the y's. It never matters. Whichever one looks easier to you, okay? Because this is already a -y and this is a positive 2y, I'm going to choose the y's. Then I only have to multiply this by 2, right? If I distribute that 2, then I'll have a positive 2y on top, -2y on the bottom. So I'm going to start by rewriting this guy. 5x plus 2y equals -5 because I don't need to do anything to it. Good. And then here, 2 times x is 2x, 2 times y is -2y, 2 times 6 is 12. So I distributed that 2 to the x, the -y, and the 6. And remember, I'm combining them. So 5x and 2x, they were both positive, become a 7x. 2y minus 2y are canceled. 12 plus a -5 is the same as 12 minus 5, which is 7. Good. 7x equals 7. Now I just solve for x by dividing by 7. X is 1. Good. That's not my solution. That's half my solution. I know that my x value for the point I'm looking for is 1, but I don't know what my y value is. Now I need to take that x equals 1 and put it into either 5x plus 2y equals -5 or x minus y equals 6. Okay. This one looks easier. X minus y equals 6, but it doesn't matter. So we had x minus y equals 6. X is now just 1. So instead of x, I'm going to write 1. 1 minus y equals 6. Maybe you think the other one's easier because it wasn't a -y. You could be right. Subtract 1 because I'm solving for y. Now I have -y equals 5. If I want to get rid of that negative, I either multiply or divide by a -1 on both sides. -1 times a -y makes it a positive y. -1 times a positive 5 makes it a -5. So when x is 1, y is -5. Is that true for both of my equations? 5 times x plus 2 times y equals -5. Becomes 5 times 1 plus 2 times -5 equals -5. 5 plus -10 equals -5. I would say that's true, right? -10 plus 5 is just a -5 equals -5. Our other one was x minus y equals 6. So that's 1 minus -5 equals 6. 1 plus 5 is 6. Also true. Good. All right, there are situations in which both variables might eliminate. Okay. Both variables eliminating means there is no x value and no y value. When you try to eliminate one of them, they both disappear. Okay. In these two examples, for these two examples, we had a point for each of them, right? The answer to this ended up being -4, 3, the point. The answer to this ended up being 1, -5, the point, right? One solution for each system. But in special systems, when you try to eliminate, you will not be able to eliminate them cleanly, okay? You've knocked them both out. If the remaining equation is true without x or y's, then that means it is consistent. There are infinitely many solutions. They are on the same line, okay? If when you have no x's and you have no y's, no x's, no y's, the equation is false, there is no solution. It is inconsistent. Okay. So here are two examples where, I don't know, perhaps we might, in trying to eliminate an x or y, eliminate both variables. Okay. So we have 7x plus y equals 4, 14x plus 2y equals 1. If you just look at this, right? 17x and 4x, what do they have in common? 14x is 7x times 2. 2y is also y times 2. But 1 is not 4 times 2. Interesting. Okay, so I want to eliminate either the x's or the y's. It doesn't matter. I'm going to choose the y's because they're smaller. Okay, I have a positive 2y here and I have a positive y here. I need to change this one. I need to make it bigger and I need to make it negative. So I'm going to multiply it by a -2. If I multiply this y by -2, I get -2y and I can eliminate it. Now rewrite it. 7x times -2 is a -14x. Y times -2 is a -2y equals 4 times -2 is a -8. So that's my first one. This one stays the same. Positive 14x plus a 2y equals 1. Okay. 14x minus 14x, 0, right? Because we're combining them. -2y plus 2y, 0. So I guess we have 0 plus 0 equals -8 plus 1, -7. So we have 0 equals -7. Do you think this is true? They are the same line, or false? They are not ever going to touch. It is false, right? 0 is not equal to -7, so this is no solution. Inconsistent. Here I have 4x minus y equals 6, -12x plus 3y equals -18. 4 and -12. So if I multiply 4 by a -3, I get -12. If I multiply -y by a -3, I get +3. If I can multiply 6 by -3, I get -18. Okay, so this might just be an unsimplified version of this, right? If I divide out -3, I'll just end up with that. Anyway, I want to eliminate the x's or the y's. The y's are smaller, so I'm going to again eliminate the y's by multiplying here by 3. Or you could divide here by 3 if you want, if they're all happen to be divisible by 3. 4x times 3 becomes a positive 12x. -y times 3 becomes a -3y. And positive 6 times positive 3 is a positive 18. Just making things up now. I'll write the other one, -12x right below it, plus 3y in the y column equals -18 below the positive 18. This is just 0. We're combining them. This is also 0. 0 plus 0 equals 0. 0 equals 0. That is true, right? And so that means it is infinite solutions. These are the same line. Consistent. And we can tell because if I take this graph, or sorry, I have 4x minus y equals 6. If I take negative 12x plus 3y equals negative 18, and I divide this all by one number, right, by a negative 3, negative 12x by negative 3, 3y by negative 3, negative 18 by negative 3, what I get is 4x plus, sorry, minus y equals 6. So I get that equation just by simplifying this one. That's how I know they're on the same line. We just took this, reduced it by a negative 3. All right. Now we'll just do a few more examples, okay? 7, now this one's. Let's not do this one. We already did this one. We already did this one, right? All right, make up a new one. X plus 2y is 4. 3x plus 6y is 18. Good. Make sure your x's and your y's are lined up. And then eliminate one, okay? I have x plus 2y equals 4 and 3x plus 6y equals 18. I'll do the x's this time. I have a 3x and an x. So I'm going to multiply all this by negative 3. You can also go like this. More professional. All right, negative 3 times x becomes a negative 3x. Negative 3 times a positive 2 is a negative 6. Negative 3 times 4 is a negative 12. And then the other one stays the same. So we'll just keep 3x plus 6. Sorry, I forgot that y. Y equals 18. Those eliminate. Those eliminate. 18 minus 12 is 6. So we have 0 equals 6. That is not true, right? This is false. So this is no solution. And this is inconsistent. Three x minus 2y equals 0 and 5x plus 10y equals 4. My x's are 3 and 5. My y's are negative 2 and positive 10. So it would be easier to multiply this by a factor that gives me a negative 10y, right? Cancel out the y's. So if I want a negative 10y, I need to multiply negative 2 by a positive 5. So I'm going to take all of this, multiply it by 5, multiply 0 by 5. Good. All right. So 3 times 5 becomes 15x. Negative 2 by 5 becomes negative 10. But 0 times 5 is just 0. That second one was 5x plus 10y equals 4. Good. 15x and 5x, because we're combining them, is 20x. Negative 10y and positive 10y cancel out, equals 4 plus 0 is just 4. Good. Solving for x. X equals 4 20s, or 4 and 20. I can divide them both by 4, right? I get 1/5. Because 4 divided by 4 is 1/20. 20 divided by 4 is 5. X is 1/5. X is 1/5, but I still, remember, I'm not done. I still need to find my Y. Which one of these Y's is going to do well with a fraction? Probably this one where I'm multiplying it by 10. Yeah. So I'm going to take this 5x plus 10y equals 4. And I'm going to put in, oh yeah, this is going to work fine. Thought I was solving for y, but I had solved for x. So now I have 5, and instead of x, I am multiplying that 5 by 1/5. What does that mean? Plus 10y, oops, equals 4. Good. 5 times 1/5, 5 over 1 times 1 over 5, essentially, right? If I turned that into a fraction and then multiplied straight across, I would get 5 over 5, which is just 1, right? 5 times 1 is 5. 1 times 5 on the bottom is 5. Plus 10y equals 4. But 5 divided by 5 is just 1. So 1 plus 10y equals 4. 10y equals 3. Because I needed to subtract that 1. So y is 3 over 10. When x is 1/5, y is 3/10. That was a hard one. So that is my point. 1/5, 3/10. They should intersect there. Last example, we have a situation in which we have no x. So I have no x here, I just have y. You can set it up, you can't do it. You could set it up to try to eliminate y, I guess. But it would be better to just solve for y right here, okay? Negative 2y equals -8. Okay, there was only one variable. The only reason we're eliminating is because we have more than one variable, but here we only have one variable, so just solve for y. Y is 8 divided by 2 is 4, negative divided by negative is a positive. So in both of these, when y is 4, you will find, when y is 4, this will be true. And when y is 4, we will find an x for this to be true as well. Good. So I know what y is. It doesn't help me to put y back into here. I want to find x, so I need to put y in up there. That equation was 4x plus 5y equals -3, right? So now that becomes 4x plus 5 times 4 equals -3. Good. 4x plus 5 times 4 is 20 equals -3. Good. Sorry. Subtract 20 from both sides. I just get 4x on this side. -3 plus -20 combined is a -23. Divide by 4. Divide by 4. X is -23/4. When x is -23/4 and y is 4, both of those equations will be true. So that is how you solve systems of equations, or you put it into Desmos and you find the point at which they intersect by graphing. Good.